At a depth of 34 meters beneath the Java Sea, somewhere between silence and darkness, a machine that once carried hundreds of lives now rests in the silt. Its registration, PK-RXA, is barely legible, half consumed by marine growth and years of saltwater corrosion. Its engines, once capable of generating 27,000 pounds of thrust each, are sealed shut by sediment and time. Most people who know this aircraft believe it will never fly again. This is the story of why they are wrong. The Boeing 737 MAX 8, a narrow-body, single-aisle commercial jet produced at Boeing's Renton facility in Washington state, powered by twin CFM International LEAP 1B engines, each generating a maximum thrust of 27,300 pounds-force. The MAX 8 was designed as the next evolution of the world's best-selling commercial aircraft family, with a standard seating capacity of 162 to 178 passengers, a maximum range of 3,550 nautical miles, and a cruise altitude of 41,000 feet. It represented the cutting edge of short to medium haul aviation. PK-RXA carried that registration as
hitting
part
the
of
rear
its
section now,
operational
stand
identity
clear
in
below.
Indonesian commercial aviation.
All right, keep
the
it
Java
steady.
Sea, where it now rests, is one of the most heavily trafficked maritime corridors in Southeast Asia. A body of water with an average depth of just 46 meters, surrounded by the islands of Java, Sumatra, Kalimantan, and Sulawesi. It is a sea that has witnessed more than its share of tragedy, and now it is the starting point of what may be the most technically complex aircraft restoration project ever attempted. The discovery phase alone required 12 days of coordinated deep-sea survey operations. According to dive team documentation reviewed during this project, the aircraft was located resting at a 12-degree port list, meaning its left wing was depressed toward the seafloor, with its nose embedded approximately 40 centimeters into the Java Sea silt. The fuselage was structurally intact. That single fact changed everything. When the survey team's underwater remotely operated vehicle first mapped the full silhouette of PK-RXA, the data revealed something remarkable. Despite the corrosion, despite the marine biofouling that had colonized every horizontal surface, despite the sediment that had filled portions of the cabin interior through the fractured oval windows, the primary load-bearing structure of the aircraft remained sound. The carbon steel fuselage frames, the aluminum skin panels, the wing box assembly, all of it still there, still coherent. The initial assessment, conducted by a structural engineering team familiar with Boeing's 737 MAX series airframe specifications, confirmed what the sonar had suggested. PK-RXA was a candidate for full restoration, not a partial restoration, not a museum piece, a complete, comprehensive, ground-up rebuilding of an aircraft that had been sitting at the bottom of the Java Sea. The extraction operation itself was designed in 3 phases. Phase 1. Marine growth removal and structural survey at depth. Phase 2. Rigging. The attachment of 3 primary lift slings to the fuselage at load-bearing points specified by Boeing's structural documentation, rated collectively for a suspended load exceeding 45 metric tons. Phase 3. The lift itself, executed using an anchor handling tug supply vessel equipped with a main crane rated at 250 metric tons. Reuters reported extensively on similar deep-sea salvage operations in Southeast Asian waters, noting that the combination of warm water temperatures, high biological activity, and shallow to medium depths in the Java Sea creates some of the most aggressive corrosion environments for aviation-grade aluminum alloys anywhere in the world. The challenge was not simply lifting PK-RXA from the seafloor. The challenge was doing so without compromising the structural integrity that made restoration viable in the first place. On the day of the lift, 4 tugboats held station around the salvage barge, maintaining position against a 12-knot surface current. The main crane engaged at 6:14 local time. At 9:47, the nose of PK-RXA broke the surface of the Java Sea for the first time in years. Water cascading from every opening, from the fractured windows, from the L1 door that had remained open at 40 degrees throughout its time on the seafloor. from the wheel wells where the landing gear had been retracted at the moment the aircraft entered the water. Al Jazeera's aviation correspondent, in a 2023 analysis of aircraft recovery operations across the Asia-Pacific region, described the moment when a recovered aircraft first clears the waterline as the single most emotionally significant event in any salvage operation, the point at which possibility becomes tangible. For the team aboard the salvage barge that morning, watching PK-RXA emerge from the Java Sea, dripping and encrusted but intact, that description felt entirely accurate. The restoration process was divided into 8 distinct phases.